okay? And actually the first thing I want to do is I just want to fill in this row right here, okay? Because I think once we fill in this row, you'll be able to figure out what is your 1-to-1 ratio, and then also what is your theoretical yield for everything. Okay, so we'll fill out all of page 5 and then like one row in page 6. Okay, so this is our map. And you'll notice that mass of water and mass of this compound have been crossed out. I'm just going to cross them out up here too. Okay, we just don't care about them. Okay, so as far as we're concerned, we just have 1 mole of baking soda, 1 mole of acetic acid yields 1 mole of carbon dioxide. Okay, like we know that there's other stuff going on, but we're not measuring those, so that's why I'm kind of ignoring it. Okay, so the first thing that we need to do, and this was something that I wrote on my other page. Oops. Let me just go back to that really quickly. We always need to know the number of moles of reactant, okay? So that's the first thing that we're going to do. So you'll notice if you look at this, you'll notice that we're given moles of acetic acid. We are not given moles of baking soda, okay? So that means that we need to do a conversion here, okay? So we're going to do a conversion from moles of grams of baking soda to moles of baking soda, okay? Okay, so before I even look at this, what I'm going to do is I'm going to write down what I am given. And again, if I look at my data, I have 1 gram of baking soda. So 1 gram of baking soda. And I put that over 1. Okay? Again, it's very important that we're using our labels here. We want to make sure that we are using baking soda. Okay, so you don't have to write out the whole baking soda compound. You can just use the BS abbreviation here. Before I even look at my map, I know that because I have gram of baking soda here, I know that I also have gram of baking soda down here. Okay, without even looking at anything, because these units are always the same. Okay, so now I'm going to look at my map. And I want to look for grams of baking soda. And that's just right here. So from gram of baking soda, and I'm going to moles of baking soda. Do we see how there's only 1 arrow in between those two? That tells me that I only am going to need 1 fraction to convert between grams and moles. And this is something that we should know how to do this, because this is what we were assessed on like a couple weeks ago. Okay, so according to this, 1 mole of baking soda is equal to 84.01 grams of baking soda. So I'm going to put the 84.01 next to the grams, and then the 1 mole of baking soda up top. And then that's just equal. Okay. Then I get out my calculator. And you want to always, you multiply across, and then you divide down, okay? And this becomes a lot more complex. So I'm going to really start solving the numerator, put an answer here, solve the denominator, put an answer here, and then divide. Even though, like, you all can tell, like, we have a lot of ones here, like, you could probably do this in 1 step. I really want us to get in the habit of setting up our problems to allow for an increase in complexity. Okay, so 1 times 1 is equal to 1. 1 times 84.01 is equal to 84.01, right? So 1 divided by 84.01, and we end up with this answer, okay? Here's what we want to round. We want to round so that we have at least 2 non-zero digits. Okay, so my answer here is 0.012 mole of baking soda. Okay, so now I'm going to look back at my chart. And here, mole of baking soda, grab my baking soda. So for mine, I only have to do this conversion once. Yours might look a little bit different. 0.12. Okay, so yeah, so just a reminder, my data says that I have 1 gram of baking soda for each of these, which is why my math is set up this way. Okay, so again, this number is going to be different for you, but the rest of this should be set up the same. Okay. Okay, so now we want to think through what the theoretical yield is going to be for what is produced. And this is another situation where these are all going to be different for everyone's data. Okay, so if you have data set 1, your information is going to be different than if you had data set 4. Okay, everyone's data is a little bit different. All right, no one has the data that I have, so no one should have the same values that I have. Okay. Okay, so for theoretical yields, we need to figure out which number is smaller. So I'm actually just going to type that into here. Oops. So which mole's value is smaller? And again, this only works because we have a 1-to-1 ratio, oops, in our balanced equation. Okay, so we are looking at the moles of acetic acid and the moles of baking soda. And you are trying to sort out which one of those values is larger. Okay? So if I'm comparing 0.004 to 0.012, do we see how these decimals, if you're just looking at this, I could see how easily we could get these flipped, okay? So if you're the person who is looking at this and the decimals are throwing you, here's my suggestion. Take your calculator. Oops. Take your calculator and literally just multiply these numbers by 100 and see which number is bigger. So 0.004 times 100, and I got, whoops, do that right. 0.004 times 100, and I get 0.4. 0.012 times 100, and I get 1.2. Do we see how that kind of pieces that out a little bit easier? Okay. I know some of us might be thinking that's silly, but I know, like, looking at fractions are just, decimal points can be a little bit goofy sometimes, okay? So just to kind of offer that if we need it. Okay, so the smaller number for me is the 0.004. So I'm just going to copy and paste that here, okay? And then I'm going to do the same thing with the rest of these numbers. So I'm going to compare within each of my ratios. I'm going to compare the moles of baking soda to my moles of acetic acid, and whichever one is smaller, that's the one that I'm putting in this final box. Okay, so between these two numbers, the 0.008 is smaller. Between these two numbers, do we see how they're the same? So it's just going to be the 0.012. Between these two numbers, it's the 0.012. And between these two numbers, oops, it's going to be the 0.012. Okay? So take a second, go through, be careful. Okay, so like with this one, if I was confused about this specific one, I would again go to my calculator. 0.02 times 100, and I get 2.012 0.01, whoops, 0.01, oh my goodness, 0.012 times 100, and I end up with 1.2, okay? So if the decimals are throwing you, double check by multiplying them by some number to make the number bigger, okay? How do I know that ratio 3 is my 1-to-1 ratio? So I know this because it has the exact same, because moles of acetic acid equal moles of baking soda. Okay, so do we see that, how these two values are exactly the same? That means that this is our 1-to-1 ratio. A good check to see if you've done the math on this page correct, you should also have a 1-to-1 ratio. It may not be number 3. It also may not be that your 1-to-1 ratio includes 0.012,